40 तक तो खिंचवा दीजिएगा। Good evening and welcome to the lecture 1 of live lecture series of subject signal system KEC 403, department of AKGEC. So let us start with the introduction to signals. So basically signals, we are using the signals from the ancient times so that we can transfer the information from one place to another one. But in this particular subject we are interested in those signals which can be represented basically mathematically. So how contained in the signal? In form of a pattern of variation of some form. Like you can see in a RC circuit network, let us suppose if we are having a voltage source here and resistance and capacitance is there, voltage across capacitor is, let's say, VC. So we can say if we will draw the pattern of changing this voltage source with respect to time, or voltage across capacitor with respect to time, so the pattern that we will obtain is basically the signal. And here in this particular subject we are interested as independent variable as time. Otherwise signal can be a function of distance, position, temperature, pressure, etc. But in this particular subject the independent variable is basically the time only. So the basic example of signals that generally we encounter, so that you can say only one dimensional variables means two independent variables, let's say x and y, and based on which we will obtain the brightness of the image. And in case of video, it is basically a function of three independent variables. Now signal can be classified as continuous time and discrete time signals. This is the very broad classification of signals. So in continuous time signal, a signal is represented as xt, where t is basically the continuous variable, and in this case it is defined for a continuum of values of the independent continuous variable time t. Means time t is continuous throughout the interval, means you are having the signal at each and every instant of time. And how we will represent this continuous time signal? It is basically represented t square plus 2t. So you can say this is basically a function. If we will change the value of t in a continuous mode, then we can obtain the amplitude value y. So an example of continuous time signal is basically a speech signal. So a speech signal is basically a continuous time signal. Now if we will talk about discrete, your discrete time signal is defined only at discrete time instants, not at all the time instants, but n need to be an integer value. Now important thing is that the amplitude of the discrete time signal between two time instants is not defined actually. It is not 0, it is actually not defined. Like in continuous time signal, every time we are having the amplitude value, here we cannot define the amplitude value between two time instants. Like our continuous time function is represented by xt and it is represented by a function or a graph. Xn is basically represented by various representations, such as graphical representation, means we can represent the discrete time signal using graph or function, like xn equals to 2 to the power n is a function which we can represent in functional form. Tabular form means n and xn are there, and sequence representation, which is one of the most important form of representation of digital signal, which we know we can represent it like this: 1, 2, 3. And here arrow is there which is corresponding to n equals to 0. So example is the weekly stock market index is an example of a discrete time signal basically. Now next is continuous and discrete amplitude signal. So basically we are based on this we are having continuous and discrete amplitude signal. So means now we are talking about the amplitude of the signal, that may be continuous or discrete. So if continuous means, continuous amplitude means within a particular range, means let's say this value is a and this value is b, we are having values between a and b which are uncounted. So if values are uncounted, we can say the amplitude is continuous, and if these values are counted, or you can say in definite values of amplitude levels we are having, then we can say this is basically a discrete value signal or discrete value signal. So now if we will combine continuous time and continuous amplitude signal, so we are having 4 combination: continuous time, continuous value, continuous time, discrete value, discrete time, continuous value, and discrete time, discrete value. So this continuous time, continuous value signal is basically your analog signal, and discrete time, discrete value signal is basically the digital signal. But other than analog and digital signals, we are having signals. So like you can see here, here you can see continuous time, continuous amplitude signal means time with respect to time amplitude is continuously varying. So we are having amplitude value at each and every time instant. This you can say example of continuous time discrete amplitude signal. So you can see for each and every value of time we are having discrete values of amplitude, but these values are not infinite, these values are finite values. So we can say these values are counted. So this is an example of continuous time discrete amplitude signal. Then discrete time continuous amplitude signal. So in case of discrete time continuous amplitude signal, we can say this signal is discrete in time, but in case of amplitude we can say the level means these levels of voltages are basically uncounted. So if it is uncounted, so it is discrete time continuous amplitude signal. And discrete time discrete amplitude signal means it is discrete in time as well as in amplitude. So amplitude values are counted values. So this you can say as digital signal, and this is basically your analog signal. Now come to the system. So basically what is the role of system? So system is need to process these signals. So why we need to process the signals? Signal processing is required because generally the information contained in the signal is in raw form. So when it is in raw form, so we need to process the signal to obtain the useful information from it. Or system, if you will define system, so system is an entity that processes a set of input signals to yield another set of output signals. So you can take example of system as a filter, like you are having a filter and you are passing signal let's say xt to it, and you are getting output yt. So the output yt that you are obtaining after passing the signal xt through the filter is basically the process signal. Now how we will make the system? System may be made of physical components such as electrical, mechanical or hydraulic systems. These are the example of systems where we are realizing the system in terms of hardware. But you can say system may be anything, means software realization of computer algorithms may also be used as a system. Means you are using a system, means you are using a computer as a system in which you are using some algorithms for the processing of the signal. Then in that case you can say that is basically the software realization. Now again systems are broadly classified as continuous time systems and discrete time systems. So in case of continuous time systems, our input is basically continuous xt, and we are passing this through continuous time system and we are getting the output yt, which is also continuous. So it means continuous time signals are used to process continuous time signals. Then discrete time signals or discrete time systems are where input is discrete and you are getting the discrete output from these systems. Next we will discuss some basic signals. So one of the basic signal is unit impulse function. So now unit impulse function is of two types: continuous time unit impulse function and discrete time unit impulse function. So in case of continuous time unit impulse function, it is also called direct delta function and it is defined as delta t. So the definition of a direct delta function is it is exist only at t equals to 0. That's why we are writing it delta t equals to 0 for t not equal to 0. So when t is not equal to 0, delta t will be, you can imagine like a rectangular pulse of width epsilon and minus epsilon by 2 to epsilon by 2 and height 1 upon epsilon. So if epsilon tend to 0, then this width tend to 0 and 1 upon epsilon will become infinity. So you can say the height is infinite. So you can say amplitude in case of continuous time unit impulse function is infinity, but the overall area contained by this rectangle is fixed to 1. So this is represented by this minus infinity to infinity delta t dt equals to 1. So this we can represent it by this arrow, and we are writing it 1. So it represents that the area of continuous time unit impulse function is 1. So this we have already covered. Now discrete time unit impulse function, it is also called Kronecker delta function delta n, and it is defined as delta n equals to 1 at n equals to 0 and 0 for n not equal to 0. So you can say this is basically your delta function. This is defined only at n equals to 0, and here in this case amplitude is 1, not infinity. So amplitude is 1, and these are the shifted versions of unit impulse function delta n minus k. This we will see later on in this lecture, that at n equals delta n minus k equals to 1 at n equals to k. So you can say this is the shifted version when we are shifting the delta function to the right, and delta n plus k when we are shifting the sequence to the left. So this is delta n plus k. Now another basic function is unit step function. So continuous time unit step function is defined as ut equals to 1 for t greater than 0 and 0 for t less than 0. So important thing is that that unit step function that can be represented by ut minus t naught. So in that case this will become 1 and 0 at t greater than t naught and t less than t naught. So the value at t equals to 0 is basically undefined in this case, although we are representing it like this, but the value at t equals to 0 is basically undefined. Then the lies between continuous and discrete time is that here n is also equal to 0. So this signal is defined at n equals to 0. So we are having impulse value at n equals to 0 also here. Shifted sequence un minus k is defined as un minus k equals to 1 for n greater than equal to k, and 0 for n less than k. Now unit ramp function. So unit ramp continuous time unit ramp function is rt equals to 0 for t less than 0 or rt equals to t for t greater than 0. So rt can also be written as rt equals to t ut, and so that's why it is t greater than t rt equals to t ut. So for t less than 0 its value is 0 also, and for t greater than 0 its value is t. So you can draw this signal like this. So this is basically your t and this is your rt. So you can see it is linearly varying with time. So when the value of time is t, its amplitude is 1. So you can say this slope is basically 1 or 45 degree, and in case of discrete time signal it is represented by the discrete points, and the same definition is there. Rn equals to n times un, you can also write it like this. So n un equals to 0 for n less than 0 and n for n greater than equal to 0. Then real exponential signal. So real exponential signal in continuous time is represented as xt equals to c into e to the power at, where c and a are real parameters. It is important, c and a are real parameters. So now this c parameter will give us the amplitude value at value t equals to 0. So this is the value that we are obtaining at t equals to 0, and so when a is greater than 0, then we are having a growing exponential function, and it is like this. Okay, so if we will see this in terms of stability, so this type of system is basically generally unstable systems. And so for a greater than 0 it is growing exponential, and for a less than 0 it is basically decaying exponential. So in case of decaying exponential we are having a curve like this. So example where we can use growing exponential functions are basically used in chain reactions in atomic explosions, and the example of decaying exponentials are signals describing a wide variety of phenomena including the process of radioactive decay. So in case of radioactive decay or response of RC circuit and damper mechanical systems, we are having this type of signals. Then real exponential signal in discrete time, it is defined as xn equals to cr to the power n, where c and r are real parameters, and r equals to e to the power alpha. So we can write it xn equals to c into e to the power of alpha n, and this is, you can say, the curve that we are obtained for this signal. This is for mod r greater than 1, and this is for mod r less than 1. So these are, you can say, exponential signal and growing exponential signal, and this is basically the decaying exponential signal. Then periodic exponential signals. Here in this case, periodic exponential signals, C and A, both parameters are basically complex one. So we are taking an example xt equals to e to the power j omega naught t, where we are assuming that c equals to 1 and A is purely imaginary. So xt equals to e to the power j omega naught t. So the important property basically that we will found for this signal is that e to the power j omega naught t, e to the power j omega naught t plus t, where t is basically the time period. So we can say this, we can represent like e to the power j omega naught t into e to the power j omega naught capital T. So this equation hold when this value will be equal to 1, and this value is 1 when it is equal to e to the power j 2 pi m, then m equals to basically plus minus 1 plus minus 2 plus minus 3, and it is an integer. So now in this case, if omega naught equals to 0, then xt will be 1, which is periodic for any value of t. But if omega naught is not equal to 0, then we can find out the fundamental period, and it is defined by t naught, and this t naught is basically the smallest positive value of t. So we can calculate it by t naught equals to 2 pi upon mod of omega naught. So if we will see, because of mod of omega naught, we can say that, so that the period for signals e to the power j omega naught t and e to the power minus j omega naught t have the same fundamental period basically. Then periodic complex exponential signal discrete time. So again, the one important difference that we can see here, it is again periodic, but here periodicity is with period 2 pi. So we can say we are having two same signals at a period of 2 pi, but in case of continuous time signals at omega naught plus 2 pi, we are getting the signals which are basically distinct signals, but here we will get the same signal. And for getting the fundamental period or for periodicity of the signal with period n greater than not 0, we can write it like omega naught upon 2 pi equals to m by n. So it need to be rational. Then next is the signum function. Signum function of signum of t is defined as 1 at t greater than 0 and minus 1 for t less than 0 and 0 for t equals to 0. So this signal is means communication and control theory. And then sinc function. So sinc of t is defined as sine of pi t by pi t, and you can see according to this function, if we will put t equals to 0, so this function will be sine 0 by 0, so indeterminate basically. So we have to solve the value. So if we will take the differentiation in numerator and denominator, then put t equals to 0, so we are getting the value 1 at t equals to 0, and we are finding that 0 crossings are at 1, 2, 3, means at integer values we are getting the 0 crossings. Another similar type of signal is there where sine sinc of t is written as sine t upon t. So that is, you can say, that is the unnormalized version of the sinc function. This is the normalized version of sinc function. And in that case, if we are writing sinc function sinc of t as sine t upon t, in that case these values are replaced by pi, 2 pi, 3 pi, minus pi, minus 2 pi, like this. Now come to the transformation of independent variable. So transformation means, let's say we are having a signal xt and we want to obtain another transformed signal which can be represented by, let's say, x a t minus b, where a is basically the scaling factor and b is basically the shifting factor. Okay, so if we want to transform the signal in this manner, so we have to need to know some operations like time shifting operation. In time shifting, like this is our signal, let's say this is continuous time signal, like this is one signal and this is t and this xt, and I am shifting this signal to the right by an amount t naught. So you can say, we can write it, we can draw it like this. So this is basically t naught. So now this signal will start at t naught. And similarly for left sided signal means this signal will be started from, you can say, somewhere here, and you can say this value is t equals to minus t naught, and this signal is x of t plus t naught. Okay. So this is basically your delaying, and this is your basically advancing. And similarly in case of discrete time signal, if xn is the sequence, then xn minus k is the delayed version, where k is an integer, and xn plus n plus k is basically xn plus k is basically the advanced version of it. Now the time scaling, basically time scaling factor is there. Time scaling means, let us suppose we are having a signal like this, and we want to obtain x of 2t, means the value of a equals to 2. Then what happened if these values are, let's say, 2, so it will be the compressed version. These values are minus 1 and 1, sorry, here it is minus 2. So this is x2t, means when a is greater than 1, then it leads to the compression of the signal, and when a less than 1, then it corresponds to basically the expansion, and this is compression. Okay. Then third one is time reversal or folding or reflection. So it is also another very important function. Like if this is t and this is xt, and we want to obtain x of minus t. Okay. So reflection means we will fold this signal around this origin or this line. So we can write it is basically, this is, if this is 1, then this will become minus 1. So this is basically x of minus t. Okay, so this is basically the reflection. And another type of scaling is amplitude scaling. So this is very simple. You have to just basically scale the amplitude by a factor. So if a is greater than 1, so basically you are increasing the amplitude, and if a is basically less than 1, then we are decreasing the amplitude. Okay. So we can represent it by a. So you can say basically a greater than 1 leads to the amplification, and a less than 1 leads to the attenuation basically. Now combined operation. So we are taking one example, like if we are having a signal a, we have to draw a signal like a, capital A star x of minus at minus b. If we will do this, so all the above 4 operations that we have discussed will be there. Okay. So how we will do this? So for doing this, first of all, what we will do basically the time shifting, and then time scaling is done, and then basically we will do the reflection operation. So this is basically the preferred method. And another method is there in which you are doing time scaling first. So if you are doing time scaling first, then you can do it, but in that case you have to shift this signal by an amount b by a, not by b only. So so that's why this is basically the preferred method. And basically amplitude scaling and reflection is generally done at the last. So we will take one question. Let us draw the signal x1t equals to delta cos t. So you know delta t is not equal to 0. Delta t is not equal to 0 for t delta t is not equals to 0 for t not equal to 0, and delta cos t sorry delta just a minute, delta t equals to 0 for t not equal to 0. So delta cos t equals to 0 for cos t not equal to 0. So we have to draw this signal like basically our final answer in form of delta. So what we will do, we will draw the cos waveform, but it in dotted, but we are writing it in dotted like this. And impulses are found at where cos t is not equal to 0. So where, so you can say we are having the impulses at so basically this is the signal. Okay, so these are the final, you can say, delta cos t. Okay, because at these points the value of cos t is 0. Now again draw the signal xt equals to signum of sin pi t by t. So you know the signum function t greater than 0 and t less than 0 it is -1. So if we draw the signum of sin pi t by t, so sin pi t by t is greater than 0. So so for sin pi t by t greater than 0 we are having value 1, and sin pi t by t less than 0 we will get the value -1. Now how we will draw it? Basically again this sine function is under the signum, so your answer will be in 1 and -1. So we have drawn this line in dotted form. Okay, and we will check, let's say we are fixing some interval t, but in this period of 0 to basically pi, you can see you are having always the positive value of signum function. So that's why this value is 1, and for this range values, so that's why we are having this. So this is basically the signum function that we are getting. And one simple question, u of minus 2t plus 1 if you have to draw. So first of all you will draw xt equals to ut t and xt, so this is basically ut, and then you will draw first we will do the shifting operation. So ut plus 1, so if we will draw ut plus 1, so this signal will start at t equals to -1. Okay, then we are scaling it by, then we will do the scaling u2t. So 2t means this value will become now -1/2, and now we will do the reflection. So reflection means what we will do, because of this minus t we will write this function. So this is 1/t. So this is u of minus 2t plus 1. So this is basically the final signal that we have drawn. We can take this question xt equals to ut. So you can say this is basically ut, t xt, this is ut, minus 2 ut minus 1 means this is, let's say, 0, ut minus 1 with minus 2 sign means this magnitude is -2. So this is minus 2 ut minus 1, and ut minus 2 0, 1, 2. So this is basically ut minus 2. Okay, so now we will combine all these signals. So when we will combine this signal, first it will go till 0 to 1, but at 1 minus 2 ut minus 1 signal will occur. Here magnitude is -2, so this time we are getting this value 1 minus 2, that will be equal to -1. Now it will start like this, but at what happened at ut minus 2, again unit step signal will be there, so magnitude will be 1. So we are having this is the final answer. So basically here we comes to the end of this lecture. Because of some network issue, lecture will be started at a late time, so that we are basically ending the lecture. So if anybody is having any queries, you can ask your query in the chat box. Okay, so So let's so if there is no query, I am ending the session.